Hello everybody. Today I and my group member that is member of group 8 will make a presentation about the topic integration of subject engineering mathematics 2. Okay, first of all, let me introduce our group member. Firstly is me. My name is BOON. My registration number is 01DTK21F1015. Then is Xavier MELSON, son of Johnson. The registration number is 01DTK21F1002. The last is Wong Jing Hong. His registration number is 01DTK21F1033. Okay, now we move to our team's roles and responsibilities. On the slide, you can see this is our team's roles and responsibility, and I will in charge in making introduction of our group, team roles and responsibilities, and I will make introduction to integration. Okay, then let me start for the introduction of integration. Okay, first we need to know what is integration. As for me, I think integration is a method to calculate the integral. It is a way of adding slices to find the whole. It can be used to find areas, volumes, central points, intercept points of axis X and axis Y, and other more. Okay, and that is my part. And next, I will pass my mic to our next group member, that is Xavier MELSON.
So, terima kasih kepada Lim Iqbal. Sekarang saya akan explain. I will explain about the example of real life application of integration. So, what are the example of real life application? A. Computing the area between curves. B. Computing the volume of solids. C. Computing the work done by a varying force. And number 4 is about computing average value of a function. These are one of the example questions of real life application of integration. The question is about a bacteria colony initially has a population of 14 million bacteria. Suppose that t hours later that the population is growing at a rate of ft equals to 2t million bacteria per hour. Find the population of entire colony at time t2. So the total population of time at 2 is equals to initial population plus change in population, which is 14 million is the initial population, and you got to integrate the 2t dt. So if you integrate, you will get the change in population. So these are the workings. So when you integrate the 2t, you will get answer 4.328 million. So you plus it with the initial population, you will get 18.328 million. So nextly, I'm gonna talk about the question which was given to us, which is about a question of integration which is given to us, which is about a the point of intersection a and b between the two line y equals to 1 over 3 x square and y equals to x plus 6. So I will be explaining about the question A. So B and C, Wong Ji Hong will explain. So the A question. So we are given two equation which is y equals to 1 over 3 x square and y equals to x plus 6. So when you want to find the point of when you want to find the intersection A and B, the point of intersection between point A and point B, you got to use 1 over so we are given two value of y lah. So we can just 1 over 3x square equals to x plus 6. We can do like that because both of the equation are y equals to. So when we do that, we can bring the x value to the left hand side, which will become x and 6 lah will be to the left hand side, so it will become negative answer. So when you put the equation in the calculator, which is a quadratic equation, you can get the both x values. So you'll get x equal to 6 and x equals to -3. So when you get the x value, you must we can get the y value by substituting the x value into the y equation. So when x is 6, you can substitute in both equation. It doesn't matter, you substitute it in each one of the equation lah. So when you substitute x equals to 6, so you will get y equals to 12. So we get the first point of first coordinate of the point of intersection, which is 6, 12. So when you substitute x equals to -3, so you'll get y equation, the y answer. So the second point of intersection, coordinate of point of intersection is -3 and 3. So I have explained about the point of intersection A and B between the two lines. So next, Wong Ji Wong will explain the question for B and C. That's all. Thank you.
Okay, thanks for the talk from Xavier. I'm Wong. Now I will continue to talk about the part solution of B, C and part summary. So when we do the part B, we need the y-intercept of point C. If we need to do the point C, we need to take the y-intersection, that is y equal to x plus 6. When we need to take the y-intercept, we must assume the x will become 0, so y will equal 0 plus 6, so we get 6, y equal to 6. So the intercept point, we can assume it as 0, 6. And then now we do the last one, the area under the curve for the region bounded by the curve at axis. When we do this, we need to separate the different part to do this. We assume the first one is the answer that we need to get. As we need to get the answer, we need to separate 3 parts, that is part A, part B, part C. The second is part A, the third is part B, and then the fourth is part C. So when we do the part A first, we need to do the integration. The B will become 6 and the A will become -3, and then s plus 6 dx, and then we minus the part B. The B will be the integration, B becomes 6, A becomes 0 and 1 per 3 s power of 2 dx. And the part C we also take out, so we take out part B 0, part A -3 integration 1 per 3 s power of 2 dx. And then now we continue to do the intersection. First, we can get the intersection s power of 2 per 2 and plus 6x, and then the BA is 6 -3, and then we continue minus the s power of 3 per 9. B will become 6 and A will become 0, and we continue to minus s power of 3 per 9. The B will become 0 and then A will become -3. So we get the answer in the part A is 54 minus -13.5, and then we continue to minus the part B, 24 minus 0, and we continue to minus the part C, so minus 0 and then minus -3. So we get the last answer, we will get 40.5 unit power of 2 as the area. Okay, in summary, we get to explore and study on our own for the topic area under the graph. The formula that we use is integration BA fx dx, and fx is equal to y. By solving two simultaneous functions y equal to x plus 6 and y equals to 1 per 3 x power 2, we get two intersection points which are 6, 12 and negative 3, 3. When searching for a point which is y-intercept, we substitute x equal to 0 in either y function to get the y-intercept 0, 6. But last not least, we use definite integral to find the area of the shaded region by using the limit x equal to 3 until x equal to 6. The area that we get from the integration is 40.5 unit power of 2.
And that's all for our presentation today. Thank you and hope you have a nice day.